Our founder president has also is watching now, because he wanted to hear you. What all, because even though he is very busy with other things, he is also joined Dr. Ashok Chauhan, the founder of the whole Amity universities, educational institutions. So I want to tell students that you are also joined by our founder president, Dr. Chauhan.
Here is the founder president.
Founder president, sir. Thank you, sir. Welcome. Welcome, sir.
From myself, welcoming Pradeep ji and Soni ji, because you very rightly told this visit of there will change the scenario in our defense area. And I would ask that you are going to meet tomorrow Satish Reddy ji. Tell her this is the newest lecture today, the latest. Because
absolutely, sir. I in fact briefed Prateek that I'll be meeting that Satish Reddy tomorrow. I'll mention about all that what we are going to do together with you.
My dear students and all participants, in the present geopolitical scenario, nothing is more important than the military power. Any day, China can attack you. And Russia and America can say we will remain neutral. Then we have to totally depend, like Ukraine, our own military power, our facilities, and Dr. Silvamurthy knows everything. We talk every day about hypersonic, about the strategic missile, and the Kim Jong have brought this ballistic missile with 6,000 range. So my dear students, we should think beyond our program, because we are all concerned to make India a global superpower. Nowhere, no, I will say no government organization is thinking like you. We want to make India strong. And this today's webinar, Atul Thakur also, I compliment you. Dr. Silvamurthy already ran. Dr. P.B. Sharma is a great technocrat. So I think this meeting will change the scenario of my MTech students. I have requested Neeraj Kumar from AIDT, Noida, to also, if your students can join, they should all join. I'm also getting it recorded, so that if the 52 students in Noida cannot join now because of class, I will see that Dr. Silvamurthy, in your presence, Dr. Kapoor, Jal Kapoor, they all see it. This is so immensely important.
Yes.
My heartiest welcome. Soni ji, my heartiest welcome. Thank you very much.
Thank you, Founder President, for in spite of your extremely busy schedule, that shows the importance you have given to research and innovation, particularly defense technology related research innovation. Thank you very much. Grateful to you, sir.
Order, sir. I got 10 minutes before your order.
Thank you so much, sir.
Sir,
you can start at time.
Can we start?
Yeah.
वक्रतुंड महाकाय सूर्यकोटि समप्रभ निर्विघ्नं कुरुदेव सर्वकार्येषु सर्वदा. A very warm good morning to one and all present here. First of all, I would like to welcome our honorable founder, President sir. Thank you, sir, for blessing us and by your gracious presence. I, Dr. Lucky Krishnan, on behalf of the Defense Cluster at AUH and Amity Center of Nanotechnology, would like to welcome you all for today's expert lecture on by our esteemed dignitaries from DRDO, Shri Pradeep Kishore and Dr. P.K. Soni. I would like to welcome Honorable VC Sir, Professor P.B. Sharma Sir, Honorable Pro Vice Chancellor Ma'am, Dr. Silvamurthy Sir, and all our defense cluster team from AUH as well as from Amity Universe. I once again welcome all our prolific and profound dignitaries on the dais and august audience. I welcome General Bal P.S. Bal sir. I would like to invite Professor Atul Thakur sir, Chief Coordinator of the Thematic Research Cluster of Defense Technology and Director ACNG for the welcome address.
Good morning, colleagues. Aligned with the vision of our Honorable Founder President, Sir, Dr. Ashok K. Chauhan, our Honorable Chancellor, Dr. Aseem Chauhan, to make self-reliant India, Amity University, in collaboration with AICTE, and DRDO has started MTech course in defense technology. And recently, we have constituted 17th research cluster as defense cluster. This is a versatile and multidisciplinary cluster comprised of scientists from MIT University Noida, MIT University Lucknow, MIT University Rajasthan, MIT University Mumbai, MIT University Jharkhand, and MIT University Haryana. The objective of forming this cluster is mainly to promote multidisciplinary research among the experts in defense technology, to share the latest updates by interacting with the specialists in this field. I'm thankful to Dr. Silvamurthy sir for encouraging and motivation. As an initiative of this defense cluster, today we are organizing 2 expert talks by Shri Pratik Kishore, Director TVL DRDO, and Dr. P.K. Soni, Joint Director TVRL DRDO, to enhance the collaboration between DRDO and academics. These 2 eminent scientists are kind enough to visit us at our campus and will discuss the defense technology challenges and opportunities, which would be very beneficial and inviting for newly launched course on defense technology. So we welcome you, sir.
So to start with today's talk, I would like to invite Shri Pratik Kishore, Director TVRL DRDO, to please start with today's lecture.
I think just before that, I would like to briefly, Atul, I would like to briefly introduce our distinguished guests. Students, faculties, you are now with the 2 very distinguished scientists of our country who have made remarkable contributions in the field of defense technology. Shri Pratik Kishore, the director, and who has spent more than 3 decades with the DRDO, particularly in the TBRL laboratory, and his signature is there in all the explosives, detonics, shock waves, armor penetration, all this domain. Our Shri Pratik Kishore, the director TBRL, has made a mark at global level. So you have very distinguished the speaker today, and we are also joined by Dr. P.K. Soni.
You are not audible, sir.
We are also joined by Dr. P.K. Soni.
Silvamurthy, sir, you are not audible.
Can you hear me now? Dr. Atul? Dr. Atul, can you hear me? Yeah, I think they can hear you. They can hear me. And Dr. Soni is the joint director at the Terminal Ballistic Research Laboratory, TBRL. Yes. It is a very important lab. Which
unmute,
is
sir.
No, I think they can hear. This is what I got the. No, you have to put the speaker on there. Atul.
Shall I start now? A very good afternoon
to all IT support.
And it's indeed an honor and privilege to be talking to the student faculty and the students and the management of Amity University, Haryana. In about next 40 to 45 minutes, I'll be talking about the defense, various challenges and in related to the defense technologies, the challenges and the opportunities that we have in the time that we are right now in. So this is basically the topic, and DRDO is, before we go to the topic, I'll rather just introduce DRDO to some of them who are not aware about of it. Do I have a pointer here? Or okay, it's okay. DRDO was established in 1958 as DRDO. And since then, it has grown from only started with 10 laboratories. Today, it has grown to 7 technology clusters and 43 laboratories. We have 6 corporate clusters to manage all the corporate affairs as well as interaction with the armed forces. We have 4 HR institutions which are specific to the training requirements of the scientists and the technical staff in DRDO. There is another society of DDR&D, which is coexisting along with the DRDO, is the ADA, which actually looks at the development of all the fighter aircraft, Tejas and LCA Mark 1 and Tejas and beyond. BrahMos is a JV, which is developing the supersonic cruise missile. We have 2 certification agencies in the DDR&D for certification of airworthiness of aircrafts as well as for the software. And there is a dedicated Institute of Armament Technology, which is a deemed university, which actually conducts specialized courses in armament technologies, MTechs and PhDs. DRDO has a present strength of almost about 7,000 plus scientists today working in various disciplines, various scientific as well as technological areas. This is the So now coming to the DRDO's journey, when we started in 1958 as basically as an inspection agency, this is basically the growth path that DRDO has charted. And if you look at beyond 2000, when the technology consolidation took place, the more and more systems and platforms are getting developed with various demonstrated capabilities. And today, the production order value of the systems and products developed by DRDO stands at more than 3.75 lakh crores. This is the order value of various systems that DRDO has developed in last about 50, 60 years, and more dominantly in last about 20 years. Now, in last about 15, 20 years, major technological gains have been there, technology consolidations have been there, and the various systems which are there with demonstrated capability, leading to the self-reliance in these areas. Missiles and bombs, there are all types of missiles and bombs, which is now within the technology domain of DRDO, whether it is a short-range surface-to-air missiles, long-range surface-to-air missiles, or air-to-surface missiles, air-to-air missiles, all are surface-to-surface missiles, all types of missiles and bombs with glide capability as well as in a normal drop capability. So all these things are within the ambit of DRDO. All the systems have been demonstrated. Many of them are already in use. The fighter aircraft capability of DRDO has been demonstrated with induction of LCA Mark 1 and Mark 1 Alpha, and other next generation aircrafts are also being worked upon. Different type of radars are already with the armed forces, and it's one of the core strength areas for DRDO, along with sonars, which is basically for all naval applications. Torpedoes and decoys for naval warfare systems that has been developed by DRDO. Electronic warfare system has already been deployed with the armed forces. The armored fighting vehicles, Arjun 1 Alpha, and the next generation tanks are also being worked upon, along with other fighting vehicles. Basically in ICVs kind of a category, in ICV category. Then guns and rockets are also one of the core areas. Pinaka multi-barrel rocket launcher system, I think you must be very well aware of. And as far as the guns are concerned, the ATAGS, the Advanced Towed Artillery Gun System, that has been developed. It is right now under user trials, and this gun ATAGS is the world's longest firing gun as on date, with the range in excess of almost everybody, that an excess by about 20% than the second number gun. So that is the capability that has been developed, and there are many other areas. These are basically the bigger system areas that I'm talking about. Now, when we are doing, we are not alone when we are doing these things. We have contribution from all the stakeholders. DRDO does the technology development. This is basically to put in perspective that any system development that we undertake, there always has to be a collaboration. It is always has to be in partnership. So DRDO gets the requirement from the armed forces, which also does the test and evaluation of the systems, because they are the primary users for this. As far as DRDO is concerned, the technology development, the system design development, to ensure the performance, whatever has been demanded, and to develop the industrial ecosystem, to support the industrial ecosystem. This is the prime responsibility where DRDO is there. In doing so, DRDO is very actively and very strongly collaborating with academia to develop the knowledge and skill base in the country, also to carry out research where the TRL levels, the technology readiness level today stands at around 1 to 3, whereas that means, I mean, we are in somewhere around basic to applied research category. We are yet to go to translational research domain, that area where we are very strongly collaborating with academic institutes. And then through academic institutes, we are also providing support to the industry in terms of technologies developed by them. Industry per se, I mean, there is general conception, DRDO, I just want to make it clear, DRDO does not manufacture systems. DRDO only does the design and development. Manufacturing always has been done by the industry. So whether it is at the prototype level or at the production level. Then the life cycle management, anything that we make has to go through, any military equipment will have a life cycle of almost about 15 years to 30 years and beyond. So all the spares, the obsolescence management, upgrades, everything during this period has to be ensured by the industry. That is what industry along with DRDO, we are able to do that. Now coming to my establishment, Terminal Ballistics Research Laboratory, which is based at Chandigarh. The core competency of TBRL is in terms of penetrating warhead technologies, all types of warheads, which actually penetrates into the target and does the damage. Then shape charge technology and EFP based technology, explosively formed penetrator based technology, that is basically for the armored and the naval targets. Then there is another core area where we are working is the high energy electrical pulse power, basically for the using the magnetic flux compression, part of generating a high power electromagnetic waves. Then when we keep doing the practice firing range, now that we know very well that the range availability or the land availability for ranges are now getting, I mean, it's shrinking, and normally which requires about 3 kilometers of range. Because of land availability, we have there is always a constraint. So baffle ranges have been specifically designed, which actually brings down the range requirement from conventionally about 500 acres to about 5 to 20 acres, depending on the range that you are planning to carry. Go to about 100 meters, but when you actually do the firing, you ensure that none of the ammunition or the bullet actually goes beyond the firing range. It gets entrapped in that area. So the new joinees, recruits actually also have a safety in doing such kind of practice firings as well, and it does not. It gives you actually the real life operational scenario feeling. So there is nothing simulated here. You fire onto the target, and although with a proper safety precaution that none of the bullets, stray bullets, actually go beyond the range, which otherwise it becomes a very big issue with the civilian population coming very close to ranges at almost all locations. Then for now the low intensity conflict operations, you have to do the crowd control or so many other things wherein you don't want lethality to be imposed. So small arm ammunition with less lethality is also being used by various Central Armed Police Forces, CAPFs. Then to initiate a warhead, the initiation of the warhead is actually done through a device called fuse. Now that fuse development is one gray area for the country, wherein now in last about 8-10 years, TBRL has started working, and we have come out with various indigenous fuses now. We started with grenade, a mechatronic fuse for grenade. Then we have gone on to and migrated to electronic fuses for mortars and aircraft delivered bombs, and migrating to artillery also. Test and performance evaluation, TBRL has a range, and test and evaluation is one of the core competencies of TBRL. And the test and evaluation, static test evaluation of all types of warheads, bombs, and shells are being done at TBRL. Either it is from DRDO establishments or from industry, or industry could be anything, ordnance factories or a private. Now private industries are also coming up with their own designs, which is being performance evaluated at TBRL. All the blast protective systems are being tested there, whether it is the boot anti-mine, which is the deminers use, or the mine protected vehicles, mine protected gears, which is also used by the deminers, and other structural elements. Then all the bulletproof jackets and helmets, we have a specialized test facility which actually does the ballistic evaluation of body and the vehicle armor. This is as per the international standards. So all the bulletproof jackets and helmets, which is used by the armed forces and by the paramilitary forces, police forces also, all the bulletproof glasses, everything that is being tested there at TBRL. We have a very special test facility called Rail Track Rocket Sled Facility, where we can actually carry out the test at component level and recover it, see whether it has performed under actual operating conditions of flight. We can create those kind of conditions on ground using a captive, using this RTRS facility. And that is being extensively used for validation of all the subsystems and even systems of missiles and other airborne systems. Then environmental test facility, whenever you develop any military stores, classifying them, qualifying them for the environment in which it is likely to be used, whether it is climatic, that is the temperature conditions, humidity conditions, dynamic, that is vibration, shock, bump, or even pyroshock, or a very high acceleration condition, centrifuge. Then EMI, EMC, and EMP for all electronic device systems. So we have full-fledged capability. And the additional capability here is for electronic systems, there are a number of agencies which are doing the EMI, EMC testing. TBRL does for the fully filled explosive system also. That is the unique capability that we have there. You can subject it to all types of conditions, temperature conditions, and very dynamic conditions, and take it to the ranges for the performance evaluation post exposure to the temperature and environmental conditions. Once the formulations are established, the technology is given to the industry for mass production. So we are mostly we are focusing on insensitive formulation. And just to apprise you that an explosive which generally inspires awe in people, that explosive looks to be a very, very dangerous component. It is definitely, but these explosives are like any other traditional material which can be casted, it can be pressed, and it can also be machined like a normal metallic material. And these are all the capabilities that we have developed in TBRL. Some of the products which we have developed in last about these all we have handed over in last about 2-3 years time. The multi-mode hand grenade, which is now being used by the Indian Army, that was developed by TBRL, has gone through all the qualification cycle, and production is already established. And the production is being done by a private industry as of now, although Ordnance Factory also is going to do the production in a short time. And this is the first ammunition actually which was manufactured by a private industry. Otherwise, till now, all the ammunitions were being manufactured only by the Ordnance factories in the country. So that is the first step, and we are meeting all the target production requirements of multi-mode hand grenade of Indian Armed Forces. Also, this grenade now has been cleared for exports, which actually brings out one major issue, or brings out a very big point, is that the Indian products designed and developed in India, manufactured in India by Indian industry, has potential to compete in international market and be exported. Generally, we are known as an importer of ammunition. So this is one example, and along with that, many other systems are also there. BrahMos, you must have read in the newspaper, that is also now, they have export clearances have been given for that. So that shows the potential of Indian design, Indian manufacturing capability to compete in a very competitive international market for arms and ammunition. Another device, that is a bunk blasting device, that has also been handed over to the Indian Army very recently. Some other products which we have developed, I talked about less lethal plastic bullets, which is used by the paramilitary forces. The exploder for the torpedoes. The torpedo, we have got a huge, very strong area for DRDO, and the exploders for those torpedoes are being done by TBRL. Then this traditional HMX is as of now known to be the most powerful of explosive, but it is used generally in a coarser particle form. But if you refine the particle to a very fine particle in the range of about 5 to 10 microns, it can also be added to propellant to increase the specific impulse of the propellant. That means, in a lesser volume, lesser weight, you can actually get more thrust. So that fine HMX particle also has been developed, and mechatronic fuse for MMHG. What you see on the screen here, the multi-mode hand grenade, it is right now with the pyro-based fuse, but we have also developed a mechatronic fuse with a very precision control on time. Then the electronic safe and arm fuse, for mortars and bombs. So these are all the products which we have developed in TBRL, and the technologies have been transferred to Indian industry for manufacturing. And it is not only the PSUs, DPSUs, but in all cases, at least one private industry also is one of the TOT holders. So that way the industry support actually is now taking us towards Atmanirbharta. Another key test facility I talked about, the RTRS test facility, where actually we can test all armament and aerospace system. As you see, it's a railway line. There are 5 tracks, which is almost about 4 kilometers. You can see the parachute testing being done there. So this actually you can test up to about 1000 kg of payload on this. You can create a condition. Otherwise, I mean, if you have to test a parachute, you can very well imagine what you have to do. You have to fly, you have to test, drop it, do the instrumentation. And if it does not succeed, you don't have a recovery mechanism to see what has not functioned. In this particular case, everything can be retrieved back. You can see which part has functioned, which part has not functioned, why it has not functioned. You can do the analysis, any improvement, any upgrade that you can carry out. So this facility is being used now that there are 5 rails. So actually you can create an interceptor situation also, which means on 2 of the tracks or 2 of the tracks, basically you can move the object in the forward direction. The other 2 tracks, actually you can move the object in the reverse direction. And then whenever they cross over, you can actually see whether the proximity sensors are working or not at that particular speed. So instead of depending on what you actually do in the lab condition, you can actually validate on ground. Then we have very specialized facilities called 2-stage light gas gun. Traditionally, we talk in terms of velocities. When we talk in terms of velocities, even the ordnance velocity is of the order of about 800 meters per second. Here we talk in terms of velocities in around 8.5 kilometers per second. Now, this actually is a condition which generally you will not have on ground, but it is all when you talk in terms of your space shuttles. The relative velocities are of this order. So if you have to save your space modules or crew modules or spacecraft, which where all the space debris are going to come at this relative velocity, around 8 kilometers and plus. So how do you test? How do you validate your protective mechanisms? So this is a condition. This is a test facility. On ground, you can actually project a mass of almost about 0.5 to 0.8 gram, about 5 to 8 millimeter in size, and make it impact onto the shield that is actually protecting your modules or spacecraft, and see the efficacy of the protective material. Then the fragment launching gun for more traditional application, that is for more unconventional application. Fragment launching gun is for more traditional application, and there you can actually launch up to 2 kilometers per second. So what these test facilities imply is what you generally do with the in-service weapon systems. They are much beyond that, and specialized test conditions you can create. These are the areas which has got huge potential. If you really want to do the material characterization at high strain rate studies or at higher deformation rates, how do you actually characterize a material or a composite? How do you make sure that a material has capability to withstand the impact on it? So all these test facilities actually are used for those kind of studies. Then split Hopkinson pressure bar, a very specialized test facility where we have capability to go to 10 to the power 4 per second. There are other establishments also now have this kind of a facility. But advantage with us is we can even characterize explosives or propellants, that is energetic material which are otherwise dangerous to test in a normal lab condition. Then of course the environmental test facility, whatever is required for a military store, we have full-fledged capability for all electronics as well as explosive and even the propellants, propellants and the pyros. Complete test facility range is available with us. We use arena layout for lethality assessment of shells, bombs, and warheads. We can do the fragment velocity whenever any explosion takes place. A lot of splinters come out, which we call as fragments. I mean, if they are already embedded into the system, we call them as splinters. If the casing itself breaks into multiple parts, we call it as fragments. So you can actually see the effectiveness of a shell and a bomb by measuring the fragment velocity. You can also look at the mass and the spatial distribution. That means, I mean, a shell is always designed to carry out certain kind of inflict certain damage onto the target. So the target, the damage onto the target is dependent on what is the mass of the fragment that is coming out, at what velocity it's going to hit. The velocity actually also determines the range to which actually you can, the projectile or the fragments actually can do the damage. So all those studies, including whenever you do the detonation, there is always a blast wave which will be actually there. So how much is the blast pressure? What is the impulse? That is, what is the damage potential of the explosive to carry out structural damage, to do vehicular damage, or to do anti-personnel damage. So those studies are done here. Then the instrumented ballistic range is where we do all the evaluation of all bulletproof jackets, ballistic helmets, all personal protective gears against standard ammunition. And then also we are also, working out on the semi-engineered product against small arms ammunition. Photography looks to be a very casual thing. Where everybody uses a mobile camera now. But we have the capability to see an object in a static frame mode if it is moving at a velocity of 8 kilometers per second. For us, that is a static event. An object moving at 8,000 meters per second is a static event for us. So that is our diagnostic capability. That is our photographic capability. So you can imagine the scaling. And we can see the detonation front, which that means whenever you do the explosion, the detonation front moving into the explosive, that is what you can see. So, and for us, it is static. So generally in TBRL terms, when we say it's a fast event, we always talk in terms of 5 kilometers per second and beyond. For us, the slowest event is about 1,000 meters per second. So that is our scale. So generally, when we talk in terms of crash impact analysis of vehicles, particularly passenger cars, that is generally done at an impact velocity of 60 kilometers per hour to maybe about 80 kilometers per hour. For us, that is almost it remains stationary. For us, that's a stationary thing. So you can say, 60 kilometers per hour is about 15 meters per second kind of a thing. Whereas for all these equipment and the sensors that we deploy have that kind of a time resolution. So you have to, because the detonation is a very, very short time phenomena, you have to acquire the data in that phenomena before the sensor gets destroyed. If you are in the zone of hit, the sensor also may get destroyed. So it has to actually capture the data, transmit the data before it itself gets destroyed. So those kind of capabilities we have. That same type of systems are also used for the blast and damage studies, whether the blast is done in air or it is underground or it is in water. And all the three phenomena are very, very different from each other. So you cannot actually take it in air and you can put it onto for the same application. For the same explosive, you can put it for the underwater application. So they are very, very different phenomena. You have to characterize the explosive, and based on its potential, you have to identify which explosive is suitable for what kind of application. Then to diagnose various kind of systems, we have a 480 kV flash radiography system, multiple channels. So you can see the object moving in real time actually at 3 or 4 instances. Then carrying out experiment is one of the simplest things. Actually understanding the experiment before you carry out the experiment, and to understand what you actually want from the experiment, that is much more critical. And that also determines what kind of sensor deployment you need to have, what kind of accuracies you are looking at, what kind of repeatability in an experiment you are looking at. To do that, we have full modeling and simulation capabilities. That is one of our areas. However, there are certain gaps in one of the subsequent slides. I'll come to that, where actually the gaps are, where the researchers or the academic institutes are actually going to have a major role to play. Now coming to the defense technologies, and first I will take the challenges and then come to the opportunities. I'm just going to present 2 of the operational scenarios. Whole of the warfare, if we look at, and General Bal is there, so maybe I think he also will have his own points on that. In the operational scenario, the first thing is don't get detected. Second is, even if you are detected, don't get hit. Third is, even if you get hit, survive. That is the first operational scenario. That is, if I am being attacked, this is how I will look at it. I should not get detected. If I get detected, I should take evasive action. I should not get hit. If I am getting hit for some reason, I should have enough mechanism within me. I should have enough strength within myself that I should survive the hit. That is the whole philosophy. As if I'm being attacked. If I have to inflict damage, what do I do? is exactly the opposite. You have to hit before you get detected. Otherwise, the target will move away, or target will take a retaliatory action. You will get hit. The second is, if you hit, you make sure that the hit is actually damaging to the target, that is beyond its survivability. On one side, we are talking in terms of myself surviving. Second part, I am talking of my target not surviving. So these are the two requirements which, I mean, two extremes in which the defense technologies work. And third is, and which is now becoming much and much more and more prevalent, is you detect and disable the intelligence network or intelligence of the enemy before getting detected. You detect. Otherwise, if he detects you, he is going to have a hit on you. So you have these all have implications. When we talk in terms of challenges, these all have implications in terms of your range, in terms of your response time, and your lethality. So coming to the challenges, of course, not in order of priority. They have just been listed as I have just recollected it. The challenge is, it is always a race between offensive and defensive capabilities. If you would have seen the two previous slides, it was one, I am in a defensive mode, second, I'm in an offensive role. So it's always a race. I have to protect myself also, but I have to also make sure that my offensive mechanism is good enough to overcome the defensive mechanism of my opponents. So one requirement, and wherever I have put the slash, they are all paradoxical. So if you want to have one, the second does not come through so easily. So these are the challenges. Like we are talking in terms of green energetics, because all explosives, they release huge amount of gases. So people do get concerned about the pollutant part of it. So people are talking in terms of using nitrogenous compound basically to reduce the pollution part of it. But the moment you do that, your energy content goes down. It does not remain that stable. Any energetic material, if it has to release the energy in a short time, it has to remain stable. The more stable a compound is, the more energy it will release when it is disintegrated. So that is the challenge now. I mean, you have to use green energetics because you have to look at the environment. Even the processing of explosives also entails so many chemicals and gases. So you have to make a process which is environmental friendly. But at the same time, you have a requirement of meeting the higher specific energy. Otherwise, to replace a conventional energetic material, you will require much more higher volume and weight, which otherwise is difficult to carry. So it's a catch-22 situation. What do? You increase the weight of the system, then your actually delivery payload becomes much smaller. So these are the challenges which generally are there in any of these systems. Similarly, when we talk in terms of protective technologies, whether we are talking in terms of personal protection, that is ballistic helmets or bullet-resistant jackets, or any of those things, or any armored fighting vehicles, tanks, or the infantry combat vehicles, or those kind of vehicles, the protective technologies require that I should have the maximum protection. My survivability should be at the best. It's the most easiest thing. If somebody is going to box me, I can put a lot of foam. What does it do? It can protect me, but it requires huge amount of space. I can put a very thick armor, a steel plate in front of me. His hands are going to get broken. But what do I have to carry? I have to carry 100 kg of my own body weight, maybe more than that. I have to carry that to protect myself. I am protecting myself, but at what cost? So that is one of the challenges. The more protection I need, I have to devise a material which is lightweight to give me that effective solution, which today I am actually doing it maybe double or triple the weight. So that is where the challenge is. Then another one is, as I said, you have to hit him before he detects you, which means you need to be standing quite far off, which is generally called as a standoff technologies. He should not be able to see me. If his hitting capability is 100 kilometers, I should hit him from 120 kilometers. Then only he is not able to hit me. So range is one of the requirements. Then precision. Now precision is, if I want to hit a particular target, I should go and hit there repeatedly. Not that, I mean, it's a tukka that I just launch something which goes as per its own wish. It should not be that. It doesn't do the damage. I mean, you have to do the damage, a particular damage. You should not do a collateral damage. That is the purpose. So you have an identified target, you should go and reach that target. So precision of reaching that target from the range. Then lethality. Having reached that, which means as you are increasing your range, your carrying capability, you need more propulsive power. Vehicle can have a limited mass to carry. It's the propulsive power which is taking the maximum of weight and volume, which means the damage mechanism, which is the warhead, actually gets reduced in weight and volume. You still need to do more damage because you want him not to survive your attack. So the warhead effectiveness has to be improved. That is where more energetic compounds, a compound or energetic molecules which can deliver more specific energy onto the target, that is what is needed. So another one is when you are hitting him, there are mechanisms that you are getting detected from where you are actually launching yourself. So he also has some mechanism. He can also move in closer so that to bring you in his hit range. So if you are hitting him, you should be able to move away from your point. Like you would have seen in boxing matches, the boxers, they never stay at one particular place. They just keep moving, shuffling around here and there. That is the purpose, that you should not, the other fellow should not be anticipate where he is going. So if you fire from a particular location, move away from that location. Even if he has acquired from where you have fired, by the time he reaches you, you are not there. So mobility, which means the systems have to be lightweight. If you have a very heavyweight system, it requires its own effort actually to move from place A to place B. Then response time. If it's a heavier system, how fast can you move? Or even if it's a lighter system, how fast can you move? Do you have 20 other systems to start before you start moving? Or it's just one command and then you start moving so even a fraction of a second in such kind of a scenario has got a huge value. Then same way is the standoff technologies. Now, when you talk in terms of standoff technologies, there are two types of things. One, you simply launch something which does the damage at the other end, which is, say, you typically consider it can be a missile or a rocket, which can go to any range, maybe 20 kilometers, maybe 100 kilometers, and maybe more. And the second type is, which means you create, when I talked in terms of C4ISR, blockage, which means you do something here, which actually should jam him at his location, which means you are not actually approaching him, but you are still inflicting that kind of a damage from here or from air, anywhere. Or you can launch something which actually reaches that point and does that damage. But whatever launches that, if you are creating a huge EM area, EM field, you yourself are in that danger zone, you yourself are vulnerable. So how do you protect yourself? So how do you avoid self-inflicting injuries? So that is one area. You have the capability to damage something else, but you have to have the potential to save yourself from the same damage. Then sensors, if you have to have detection capability at a long range, you need to have the sensors which have the capability of to go to a very high range detection capability. And it is, as you keep increasing the range, naturally the size keeps increasing, so mobility keeps coming down, so you actually tend to move more towards static installations. With the sensors, the purpose is you have to have detection, then identification. And when we talk in terms of military identification, it is always the classification, because you are not looking at all the type of targets, you are looking at certain types of targets. So you need to have the classification. And second, third, and the most important is the recognition. In such kind of a scenario, your fellows are also there, their fellows are also there. How do you distinguish between the two? That is identification of the friend and foe. So these are the very specific technology requirements in any military system. You have to have a clear identity, and you should not be hitting the friend, which is also there in the same region. Then coming more to the area where we have gaps today, where academic institutes and other R&D institutes actually can fill in, is the materials. All critical materials today, mostly they are imported as a raw material. Some of them, they are being processed in the country, and some of them are not processed also in the country, whether it is a metallic material or it's composites. And this is where we need to join hands. These are the challenges. If we really talk in terms of all these things, if you just, try to collate and take the, you just try to summarize where actually these things lead to. You need to have control on material, tailor the material to the property needs of your requirement, and you must have the capability to process it. Even if we talk in terms of large size forming, large size machining in the country, that also is today restricted or limited. So these are the areas where the gaps are, various different type of tools, working on with different kind of alloys. That is an area which need to be worked upon, both in terms of ensuring the quality, repeatability of the material quality and its manufacturing, even having manufactured, all the military materials have to go through a very stringent quality control. So the test methodology, test procedures to meet those requirements. So that is one area where we need to collaborate. Then, of course, when we talk stealth, so if you don't want to be detected, even if you are hovering near his house, you have to be stealth. You have to have that Harry Potter's what is that called? That he used to have one clock, invisibility clock. So you need to have something like that. So how do you I mean, keep yourself in the stealth mode so that the other fellow is not able to detect you when you are even on his head? Then as time goes by, more and more network-centric systems are coming in, which means, I mean, one single operator or one single command control is actually, I mean, controlling a huge area in the battlefield. So he gets all the communication, all the command control communication, computers, intelligence, surveillance, and reconnaissance. So every feature is built into one system, and therefore he can take offensive action or defensive action based on the intelligence net gathering that he has from one single command post. So these are the systems that is coming up. Another system which I think Dr. Selvamurthy would have, it was his brainchild actually, a soldier as a system. Generally, I mean, if a person goes, so this point actually, I mean, when a soldier goes to a field, people generally feel that the equipment actually helps you, but it is not always the equipment. It is also the man behind that equipment is equally important. And that is where you have to make his decision making, because it's a very short time phenomena, very short time reaction time he has. You have to enable him with all decision making aids, his ergonomic conditions, what is that called, physiological conditions should be more tuned to that operating environment so that he takes decision in that split second. So how can you improve his operating condition? So that is one of the reasons. I mean, normally an Indian soldier will carry almost about 30 to 40 kg of operating payload when he goes for his operations. How can you make him not burdened by that 40 kg? He should not feel that he is carrying 40 kg. 40 kg is essentially required for his operating requirements, operating and survivability also. He has to carry his ration, he has to carry munitions, all his weapons, everything. So how can you make him feel, either you develop a very lightweight vehicle, lightweight system, or you reduce the load that he actually carries on his person, so that something else, exoskeleton kind of a thing or something else that actually can work on this. So that is one more very, very important feature. Then modeling and simulation, when we talk in terms of modeling and simulation, high fidelity models are very, very essential, because otherwise it is going to be absolutely garbage in, garbage out. So you will get good fancy pictures which will not convey any meaning. So you have to have a very high fidelity model, which is a true representation of whatever you are doing the modeling. If I'm talking in terms of a vehicle, metallic things, it is comparatively, I'll say it's easier. You go into the humans. Now people are saying that if a person is getting hit by a bullet, whether he will be able to survive that attack or not, which means I cannot put a person there. Models are there, but what is the fidelity? That means, I mean, if I am getting a blunt trauma of say 10 millimeter backface signature into my body, what kind of damage will it cause? So those are very, very important. Like, I mean, aircraft systems, you are talking missile systems, your radar systems, all other systems. I mean, you cannot keep making numbers and numbers and keep doing experiments. So this has to be there. That modeling and simulation part has to be there, but it has to be accompanied with the high fidelity models which can be verified with the experiments and which must have some kind of a close correlation. Then various specialized test infrastructure and facilities, that are also the challenges. Like we talk in terms of any flying objects, you need to have the wind tunnels. It can be in various regions. It can be subsonic, it can be supersonic, hypersonic, or it can be in the transonic region also. Then RTRS type of facilities where actually you can, people have, like in US, there is a facility which is 16 kilometers long. What we have here is about 4 kilometers long. They can actually put a jet onto the track and see whether the jet's braking system works or not, or fighter jets, all other emergency response systems, how does it operate? The weapon opening bay, how does it operate? So they have that kind of a capability. Somewhere we have certain shortcomings. We have to create those kind of conditions in lab and partly by simulation. So both experiment and partly by simulation, that is the way we are looking at. And these ballistics and blast evaluations, it is not only that you simply fire a bullet into the bulletproof jacket and you are done with. You have to do the measurement in terms of what kind of blunt trauma it is actually causing. So whether the person, it is within the person's capability to absorb that kind of blunt trauma or no. At the end of it, all these technological solutions actually requires huge amount of funding budget. And therefore, people will always look for a cost-effective solutions. All the technological solutions have to be cost-effective. Also, we have to ensure that their operational life is long so that they are worth the money being spent. The life cycle management cost is as low as possible, which means, I mean, it should not be that, like your AC, every year you have to go and go for the cleaning and some other maintenance. The field formations cannot afford to have that kind of a system. So when we talk in terms of such kind of designs, this is absolutely essential that it remains, it requires minimum of servicing, because the armed forces, once it is deployed to them, they have so many other jobs to do. So why to have a loading on them of doing the maintenance part or the, I mean, change of spares. So if we look at the challenges and we try to summarize, we are always racing against time to manage technology obsolescence. Today, it is very, very relevant. By the time you come up with one particular design, particularly in field of electronics and computing systems, by the time you are coming up and certifying a particular product to meet its requirements, something else has come in picture. So where do you stop? Where do you say that this is my Mark 1, where it is Mark 2? And in defense technologies, you have to be better than your adversary. So you have to be also aware what your friends have across, what they have. So you have to be better than that. So that's always a very tough call to take, what somebody has and how I am better than him. Then in this particular case, the armed forces, they are very, very active. They are very, very knowledgeable, and they are very, very demanding. So and they have a very good perception of how they are going to employ different kind of systems. So their requirements are paramount, because it is they who are actually going to use it. I mean, the academicians, the R&D institutes, or the industry are not going to be there. So you have to also factor in their perception of how they are going to employ. Then threat perception changes. Something which is of no threat today becomes a very, very potent threat tomorrow. So you have to have that kind of agility and flexibility to adapt yourself to those kind of requirements. Then technology forecasting, all of us read this particular topic, but how far we are true to this? How we are able, how true is our forecasting? Because you can develop systems based on your assessment of things. So if you are far away from reality in assessing the growth of technology, we will be left behind. Somebody else, if he has hit the jackpot, he will be actually the winner in this game. And the most challenging thing is imagining what the future warfare will entail. So you have to only, this is something which you have to really become astrologer or something like that to understand how the future warfare can happen. Because person who actually sees that far will have technological edge. He will have the time to actually develop systems, capabilities which he does not have today. And therefore, he will always be in a much stronger position. This is where we will say the most critical challenge for defense technology is how it is going to entail in 10 years' time, how it is going to do in 20 years' time. That kind of a perception has to be built. That is where certain technologies which are being worked upon right now, which may be considered, it may not have a military application, will have some application, some defense-oriented application on a later date. And therefore, technology to product, that gestation period is always high, particularly more so for defense technologies, defense products. And therefore, technologies need to be worked upon and should give product development team enough time with the base of technology. Otherwise, we generally will start looking at development of technology when the product is needed. At that point in time, it does not serve much of the purpose. Now coming to the opportunities. As far as, I mean, I'm only talking with reference to the DRDO's interaction. in terms of defense technologies and our outreach. DRDO has got 10 Center of Excellences in different universities and in all domains of defense technologies, whether it is aero, whether it is computing, materials, or even life sciences. Everything we have combined into one, into Center of Excellences, and 10 Center of Excellences all across the country they are working today. And we are also supporting the extramural research, which are being done in 2 levels. One is extramural research and second is the CAS, the Contract for Acquisition of Research Services. Extramural research is generally handled by DRDO headquarters, and in the risk wherein they have a potential, these studies may have potential in defense application, but you may not have an end application in sight. That is, it is not mandatory to have an end application when you start developing the basic knowledge or the technology. These are generally managed by 4 research boards that we have: Armament Research Board, Naval Research Board, Aero, and Life Sciences Board. So all the academic institutes actually can, suo moto, can put up a proposal to these boards, take up a project. Some of them may have direct relevance to defense technology. Some of them may not have direct relevance today, but it may have some relevance tomorrow. So these are the 4 ways that research is funded in the academic institutes. And as on date, DRDO's exposure is to almost about 300 plus universities in the country. Around 1,000 plus crores investment of DRDO is there with various academic institutes in the country. Then next is the Contract for Acquisition of Research Services. This is basically for specific technological issues, which generally this is handled at the laboratory scale, because if I have certain problem, a very specific problem wherein I need intervention of academic institutes, the knowledge base which is available at the academic institutes, certain PIs who have worked in the similar kind of areas earlier, or maybe have some kind of a background knowledge to take up to address a very particular problem, which can be addressed in about say 1 year, 2 year, 3 year kind of a time frame. So these are the proposals which are handled through CARS, and every lab handles it at their own level. Up to 5 crores, the CARS project can be sanctioned in DRDO at various financial levels. Up to about 25 lakh, it can be sanctioned directly at the lab. Beyond up to from 25 to 3 crores, it is handled at cluster level in DRDO. And beyond that, it goes to Secretary DD R&D level. But this is another area where we have almost about put together TBRL itself. We have about 11 projects right now going with 7 academic institutes. This is one area of collaboration where active problems can be worked upon. So research scholars as well as MTech students who are working in this, they are generally being, they are generally getting exposure in these projects through their PIs. Then very recently, as Professor Thakur also brought out, DRDO has initiated this program of MTech in defense technologies, and many universities have already started. In one of the advantage here is the technology areas for this particular MTech program has been identified by DRDO, and there are labs who have been identified to support the research scholars in their project work. So the coursework, it can be done in the university, and the project work can be done in one of the DRDO establishments where that core competency is. Research scholars, the PhD scholars, we have now got a scheme from Ministry of Education that about 500 numbers of research scholars who are already enrolled with the universities, they can actually carry out their research works at DRDO laboratories. As of date, to best of, I think as I remember, I think about 45 institutes, I think people are already, the universities, the research scholars are already registered with them and working in different DRDO laboratories on different technology problems. Then internship is one area where we are actually engaging with the academic institutes. Now that 6 months training programs, which we have for undergraduate students, that is being done by TBRL also at all laboratories in DRDO. And generally, depending on the work content, we have almost about 70 to 100 students every 6 months. So, and it is open to all disciplines, including science disciplines also, if this kind of research work is required. One thing is if you look at the total technology spectrum in DRDO, we are working in basic sciences. You start with physics, chemistry, mathematics, then you go to the life sciences, then you come to the engineering, all branches of engineering. You start with mechanical, electrical, computers, communications, textile, chemical engineering, or aeronautical engineering. All disciplines of engineering, they have a requirement and they are being worked upon. So it's a very, very cross-disciplinary topic. Every student, every research scholar will have one or other application. He will find his area of interest in one of the DRDO establishments. So he can take internship, he can work as a research scholar there, of course, through as per the university guidelines. And if it's a MTech program in defense technology, yes, we do support universities and students for their work. When we are talking in terms of the total ecosystem, I have talked about academic institutions. Earlier, I talked about the users requirement. And now I'm coming to the third partner. If we consider DRDO, if we take DRDO away from that slide, this is the third third engagement partner, which is the industry. At one point in time, the three institutes, that is R&D institutes, the academic institutes, and the industry, they were actually three independent identities. So academic institutes will do the basic research and leave it at that. Industry will pick up from there, or R&D institutes will pick up from there, make it into translational research, take it to the product level, and then leave it for the industry to do. So what it entails is there is always a time gap between the two events. That is academic institute completing its work, R&D institute converting it into technologies and products, and industry going to produce it. So there is always a time lag, obsolescence, and of course, gaps in the knowledge transfer. Now, with this mechanism, it is now getting concurrent, which means the academic institutes and the R&D, every academic institute now have incubation centers. They have startups who are associated with them. So that is what now is a preferred model if we really want to compress the timeline and fight against obsolescence. By the time we develop a system, it should not become obsolescent. So in this regard, DRDO has partnering with 2,200 plus industries are our major partners. And if we look at the total industry base of DRDO, it is more than 13,000 industries in the country. And industry has also moved in a very, very significant manner. And the R&D culture is getting integrated in with the industry. And they are now migrating from earlier what used to be called as BTP, build to print, which means the design has been done by somebody, he gives a drawing that you please manufacture this thing. Instead of that, now we are migrating to build to specifications. That is, I say these are my requirements. The industry does the design part of it and also does the manufacturing part of it. So that actually, if you just take one step back from the BTS, actually you would be doing your own product research also. So this is what we are now trying to involve industry with. Then another scheme which has been initiated almost about 4 years ago, and it is a major program to support industry in indigenous development of products as well as indigenization of imported components through technology development funds, wherein an industry MSME can be funded up to 10 crores and a startup can be funded up to 1 crore for projects of either their suo motu proposals or of requirements projected by either the armed forces or by the DRDO establishments. So the industry actually can look at the website, DRDO website. The products are listed there and they can actually bid for that. And the advantage is once you are successful in developing the project, the funding is by the government, partial funding is by the industry. And once you are successful in developing this particular product, you have the first right to produce that. So whatever requirements in future comes, that industry who has developed it can keep producing it. So the economic viability of the industry in the long term also can be there. Then as transfer of technologies, DRDO has more than 1,000 plus technologies, and that has been transferred to industry. As I said, DRDO does the design and development and does not do the manufacturing. Manufacturing is always by industry. So the technologies are being transferred, and more than 550 industries have actually taken these technologies, which means certain industries have taken more than one technologies. Another thing, defense technologies, when we talk in terms of test facilities, they are always a very specialized test facility, and it's very capital intensive as well as the area requirements are very high because of the safety considerations. So the industries, mostly they generally will not have that kind of resources to set up these kind of specialized test facility. purely from commercial exploitation point of view. So the test facilities which has been developed by DRDO now is being offered to industry as well as to academic institutes. Now, a lot of academic institutes, they are working out their own R&D, bringing out some samples which they want to have the test and evaluation done. So all those testing is being done by DRDO. For industry, it is being done on a nominal charge basis. For industry, if it is coming as a byproduct of one of our research projects, either through CARS or through that MTech project or a PhD program, or through the research boards, those products are being tested at various laboratories in DRDO. So that you have a real translation from the lab to a product validation. So those facilities are also available now. New concept to compress the timeline, just to manage the loss of knowledge, the loss of time when translating from one stage to another stage, and to have the industry getting enabled to produce the day the development is complete, so that the armed forces get the systems in near real time, you can say. So this concept is development cum production partner, where or as a lead system integrator, he gets involved the day a development project is sanctioned in DRDO. Now we are identifying an industry partner also around the same time. He also is getting associated in the development phase. So he also learns it, and by the time the development gets completed, he is ready in a production ready mode. Also, since he is investing a lot of time, money, resources, so he also, whatever orders will be coming from the armed forces, it will be given to those agencies who are nominated as DCPP. And if you are a development cum production partner, you don't have to pay the TOTP, which otherwise is on a notional basis around 5% of the development cost. In this particular case, that 5% also is waived off. And another point that has been now given is all the patents that are held by DRDO is now available at nil cost to Indian industry to convert it into products. So this is how we are trying to engage with all the stakeholders. The challenges are very well documented. These are the opportunities. These are all integrated opportunities. Why I brought industry here is, I mean, you cannot actually isolate industry when we are talking in terms of R&D efforts in the country. If we are looking at complete self-reliance, so you need to have all the three constituents, all the four constituents, that is the user, the R&D establishments, the academic institutes, and the industry, always together. And this is how actually we will achieve the self-reliance in critical defense technologies in times to come. With that, I conclude my presentation. Thank you very much, and Jai Hind.
I have a news to share. I received a message from our Honorable Founder President, sir, to request you. Hello? I have received a message from our Honorable Founder President, sir, to request you that Amity University Haryana would like to bestow the honor of being honorary professor at Amity University Haryana. We would write you, sir, with a request to kindly accept it.
Thank you very much. Thanks a lot.
Shri Pratik ji, what a fantastic lecture it was. You know, you gave all the challenges, opportunities, and the new paradigm which DRDO has created in the recent years to very strongly connect with industries as well as academia. So I am so happy, and founder president has been watching all through the program. And so he has requested you to be the honorary professor at Amity University, Haryana. So kindly accept, we will write formally, and so that you can also take the approval from headquarters and other whatever formalities. So thank you so much. I think all the students might have immensely been benefited. And I learned quite a bit in the recent years, what all you have done at TBRL and the great job that you are doing to build the DRDO, connect with industry. And so it's amazing. Thank you so much. Atul, over to you.
Thank you very much, sir. It's an honor, sir. Thank you very much. And it's an honor. It's an honor actually, sir, that I'm talking to you. I worked with you some long time back. It's really an honor to connect with you, sir. Thank you very much, sir.
Thank you. I would also tell Dr. Satish Reddy tomorrow when I meet him, about this lecture, how you really gave the overview of the DRDO's new opportunities so that more academia, more students, more PhD scholars, MTech, everyone should come in a big way to build our national defense through technology. Thank you so much. Atul, over to you for the next lecture.
Good afternoon, all. Thank you, sir, for the opportunity to talk to Amity people, Amity students, Amity faculty, and management. And I thank Pratik sir for giving a ground to me to talk a little bit deeper into the things, because the picture you have given has given you a broad vision to the audience that what is there, what to be done there, what are the ways. I'll just pick one of the achievement which TBRL had. So among the few of the technologies and product TBRL has handed over to industry, I'll just pick one example that how that product and technology has come up to a level that now it is being handled by industry for meeting the requirement of the defense and other applications. So during his presentation, you might have seen few of the technologies which have been handed over to industry. One was the product called Fine HMX, one explosive ingredient which is now used in propellant for increasing the power of the propellant. So I take this example of technology transfer to especially students and researchers who wants to just find a way how to start with the research problem. And fortunately, I got a good response from the students when I talk about this aspect of the research, that is curiosity. You know, from the childhood, we all have one component common to all of us, curiosity. We are always curious. Why this is so, why this is so, why this is so. With the age, our curiosity reduces because we assume that we know, this also we know, this also we know. But actually we know a little. We know only the face. We don't know about the depths of the things. And here's the science comes at the rescue. Because whenever you have a curiosity, and if your curiosity drives you toward the science, toward the concepts, toward the things, then that can easily be converted to technology and product. So taking just one example, I'm sure that this afternoon is going to be a very curious afternoon. So keep awake and don't be drowsy. So generally, when we talk about the curiosity, we talk about why, what, where, and when. So every time we question these things, our curiosity takes a shape. And that curiosity, when we talk in terms of DRDO things, we talk about the thinking, learning, human development, emotions, and all those combined effects comes to play to really bring the curiosity at the fore. So when we talk about the curiosity, we think that what to be done, how to be done. And an academician, a researcher is free to think in this manner. And we will think in this manner, we think about a concept called blue sky research, where we don't know anything, what it will be. Suppose I take some things, want to see what is this and all. You just curiosity point of view, you just explore things and explore. And then you take it to the level where you find, oh, this can have some application, this can have this use. And that converts into some advantages in the science. And you will come to know that all such inventions happen in science has born out of the unplanned research, curious research only. After that, curious research really converts into a technology and product. So I'm taking one example of the curiosity. You know, all energetic materials are the explosives. So I'm talking about one explosive, its phase transformation, and how that phase transformation curiosity led to a product. We all know that explosives are part of our life, from a bullet to demolishing an old building to a nuclear weapon or seat ejection of a dying aircraft or a demolishing an old building. And if I take the history of an explosive, it started from Genghis Khan's time when black powder was used to make enemy fearful. So from black powder to today, we have around 300 different molecules which can be used as an energetic molecule. You all might have heard about the RDX and TNT. कितने लोगों ने सुना RDX? RDX का नाम सुना है ना? जब भी कोई धमाका होता है, टेररिस्ट अटैक होता है, तो जैसे कि RDX यूज हुआ. You know, this RDX explosive was discovered about 100 years back. And TNT, which is another explosive, was discovered in 1863. You know, the TNT was discovered for what? Yellow dye. They were making different colored dye, and they found that one very good yellow dye has come up. For almost 20 years, it was used as a dye only. Later on, somebody found that it burns very fast, and it burns and gives lot of fumes and pressure. So this curiosity prepared material leading to application as an explosive. So similar curiosity we also had when I was just started my research for my PhD problem. So you're knowing that RDX and HMX are explosives, and they are used for various applications of different particle size, from 1 micron to 700 micron particle size. One particular particle size, that is 5 to 20 micron, was required for increasing the propellant's power. Propellant which are used in the missiles to throw out. So they wanted something around 5 micron HMX particle, and it should have all the property, and it should be a beta polymorphic form only. Those who are little bit chemistry form, you know, कोई भी molecule exists in multiple polymorphic form, alpha, beta, gamma, delta. Some are stable, some are not stable. Here beta is the most stable, so they wanted only beta form. So it began in 1998 when I was just recruited as a scientist in DRDO and was working with one of the product called HMX production. And there we found that HMX generally is an explosive produced in 4 different polymorphic forms, but only beta form was useful. So only beta form was produced, and this was used from 50 to 800 micron for various formulation composite. When this requirement of 5 micron came, we wanted to prepare that 5 micron HMX. And we found that only one polymorph which is useful can be made in particular condition only. Other polymorphs which are less stable either need to be converted into stable polymorph or not required at all. So when we were studying about the things and finding the polymorphic forms stability and all, we found that beta form is quite stable, but all other forms is not stable, and they have a different symmetry and different properties. Those who are in chemistry probably will understand, but non-chemistry people will have a little bit difficult to understand. So I explain it this way, that these polymorphic forms exist in different configurations, molecular arrangement, and that leads to their change in property. So we found that if only beta form to be made, because that has a stability, more density, less sensitivity, how to make it? We can prepare this polymorph under different conditions. So we were found that different conditions polymorph we can prepare, and we can characterize them. They had a different molecular structure, and we can characterize them with simple FTIR spectrophotometer, and we found that they have a different peaks to characterize. So we know that 4 polymorphic forms exist. Those polymorphic forms has a different characteristics, different structure, and different spectroscopic properties. We characterized all their properties, their Raman spectrometry and all their structural performance. Then we found their interconversion. This is interesting. Here the curiosity was there. That alpha, beta, gamma, delta exist. Beta to delta conversion was reported. Delta to alpha, alpha to delta was reported. Gamma to delta, delta to gamma was reported. But beta to alpha and beta to gamma, this particular conversion was not reported. Simple curiosity, why? Why this interconversion does not happen? And we found that these conversions must be happening, but somebody did not study it. So let us see why we should study. So being as a PhD problem plus as my work problem, I combined it and I started studying the all polymorphic form in a detailed things. That as a science comes to rescue, what is the structure, how it is formed, how it can be characterized, what is their UV visible spectrophotometer, what are their forms. One interesting observation was there that alpha, beta, and gamma, they all has a different crystal structure. Triangular plate or a needle kind of things or rhombohedral kind of crystals. So this shows that we can first visually characterize them by just seeing their crystal form, how that looks. Then their density, their sensitivity, their melting point, and their stability. So one polymorphic form was stable, that is the beta, and others were little bit less stable, less denser, and having less melting point. So we must know about the phase transformation, that how it happens. What are the governing factors to make this phase transform happen, and why it happens. So if you are little bit into the chemistry, you can understand that there is a kinetic control of the crystallization and there is thermodynamic control. So thermodynamic control leads to a different kind of behavior and kinetic control leads to different kind of behavior. So we are again with the problem that these kind of interconversion, that beta to gamma and gamma to beta, was not reported, and let me understand this. So when we understanding it, we found that this transformation happens, which brings to change in spectroscopic characteristics. So that is another way to record the change and transformation. In physical form, when we found that phase transformation happens, the crystal opacity also changes. A crystal becomes blurred or not clear one. And that transformation we can reflect in terms of their sensitivity. That sensitivity also got changed. If we model the molecule, we can find out that the layout of the atomic in the crystal also changed. And that lead to change in the spectroscopic signature also. So this transformation we studied. Now I take you back to the problem of 5 micron HMX, which I presented that we require 5 micron of HMX. When we are preparing the 5 micron HMX, it converted into gamma form. We understood why conversion happens. Requirement was only beta, and if it converted to gamma, how to convert back it to the beta one. So simple curiosity was going on, and we were studying it. Then we found that if we can convert back gamma form to beta one in the same 5 micron, we can use this product. This product technology was not available, denied totally by foreign countries, and we have to make it indigenously. So I started working on that, and in around 3 years of my time of PhD, we could understood the complete polymorphism. I cannot explain the detail because the audience is not purely from the chemistry, but we understood the total polymorphic conversion, interconversion, and then we found that if we can convert back gamma to beta, then we can really make a product of 5 micron beta HMX very usefully. So we started working on that, and we found that there is thermodynamic control. The temperature and solvent condition can make it to gamma. And if we reverse the same temperature and solvent condition, we convert back it to the beta one. Yeah, please. How much energy is generated either to gamma or We wanted to measure it, but phase transformation, and that time single crystal XRD was not accessible to us. I think single crystal XRD came in Punjab University in 2011 or so. So we were not able to measure, but I can understand that fine particles can be prepared at low temperature. Supersaturation to be kept at low. So we are not able to measure all those parameters because they are very little energy change. And if it is in solution, it is further difficult to measure. So only thing we could characterize the material, that material what is coming. So when we reverse the condition, that okay, this condition favors the gamma form, and if we change the thermodynamic condition, we can convert it back to beta. And that conversion we studied, and we found that in the same mixture, you just reverse the condition. We were preparing fine at around 18-degree temperature. We changed it to something around 90-degree temperature, and it was converted to beta. Now, this is all work an academic experience only. There was a problem existing to make fine particle. There is an understanding of phase transformation. We were knowing that when we make fine particle, phase transformation happens. How to reverse it back? That we gain from the basic research, curiosity-driven science. So curiosity-driven science has solved the problem of making fine particle of HMX. And that fine particle of HMX has an application. So we started with a milligram, taken it to a gram level, kilogram level, and now 10 ton per year production facility is there in the country, and which is used in the propellant to increase the missile range, to increase the propulsion power of our satellite launch vehicle, and any other things we can use this material. So I just want to make you understand that whenever you do scientific investigation as a researcher, as an academician, as a scholar, as a student, you understand the smallest question into that, smallest curiosity into that. You know, जो सिलाई मशीन इन्वेंट किया था, वो किसने कैसे इन्वेंट किया था आपको पता है? अगर आप उसकी स्टोरी पढ़ोगे तो सिलाई मशीन को जो चलाने वाला उसका बेटा था, उसने उल्टा किया उसको, तो देखा कि वो जो धागे हैं वो 8 तरह से मिलकर के आते हैं, और अगर उनको मैं सेग्रीगेट कर लूं तो I can use it to swing people machine way, and that way the innovation happens. So smallest curiosity can lead to a product, a technology, and understanding. So now we understand that in all conditions, if I want particular polymorphic form, I can prepare that. I can do that. When I was doing the phase transform studies, I was not aware कि मेरा ये phase transformation studies मुझे क्या product देगा. But curiosity was there. कि ऐसा क्यों होता है? And that Q can lead you to the making the product and technology. So, yeah. Naturally, all conversion, as I told you, either kinetically controlled or thermodynamically controlled. If you see the reaction graph or any conversion graph, there is a product and a reactant, the energy difference. Either product must be stable, and then activation energy should be given to that. The same happens in the crystallization also. So if you can give that energy which overcome that hump of activation energy, it will convert into product. If you want to convert this product back to the things, either you provide that same energy path again and bring it here, or you kinetically create a condition where this doesn't happen, this only happens. Our problem was not reaction. Our problem was, as he told, very minute energy change. Very minute energy change which can bring the conformational change into the molecular orbit. So conformational change can be governed by very critically controlled solvent temperature conditions. So if you can understand that small change in conditions, like one of the concepts which I probably did not talk much because I thought probably people were there or not, solid state reaction. You know, how many of people you heard solid state reaction? Can you imagine two solid keeping together can react? Have you ever thought about it? Can you imagine two solid things kept in control can react? conditions. Means reaction is possible, no?
Yes, sir.
Reaction is possible. So that solid state reactions, why it happens? Have you ever curiosity? I can give a lecture on solid state reaction. That was also part of my PhD. Two solid, why they should react? Tell me why nanomaterial has a different property than a bulk material. Single line answer. Surface area. And why nanomaterial behaves differently than the bulk material? Free surface molecule. In a bulk material, in a bigger crystal, surface molecule to the bulk molecule ratio is very different than a nanomaterial. In a nanomaterial, free surface molecules are higher than the bulk molecule. So molecular interactions in that nanoparticle is different in a nanomaterial than in a micron size or a bigger material. So solid state reactions is also taking cue from that. Your surface molecules are available. They are not bound from all sides. So when you keep two surfaces together, they interact. And a beautiful reaction happens, and you will be surprised. You can have a totally different way of preparing new material by solid state reaction. So phase transformation can also happen in solid state also and in solution state also, depend upon the thermodynamic and kinetic control. So this thermodynamic and kinetic control is a scientific component, but curiosity is the first component which tell you why this happens. If I tell somebody कि ये दोनों चीजों को साथ में मत रखना, खराब हो जाएगी, अरे कैसे खराब हो जाएगी? Because the surface of this and surface of this is always in contact, and they has a tendency and potential to interact, depend upon the conditions. और इंडिया में conditions 0 डिग्री से 50 डिग्री तक एग्जिस्ट करती है, 10% ह्यूमिडिटी से 100% ह्यूमिडिटी एग्जिस्ट करती है, and 99% of material under these two conditions are liable to react, and that's why our material deteriorate with the time and conditions. So any conditions, if you understand reacts, you can try to protect that reactions, and that is what the coating science comes into the picture, and all nanoscience and all coating science take advantage from this concept, that how to immobilize the surface so that it doesn't break. So this curiosity has led to understand the phase transformation and so many other concepts. Solid state reaction I learned from all these things, and we found that one very interesting things which was not reported in the literature, that gamma form, why it is stable, because as I told you, it forms when I prepare fine particle, it forms. But why it is stable, why it exists, I have come to know that it requires one molecule of water to be present to make the gamma happen. So this given me another clue. If I remove this water molecule, I can get it back to the beta one, because this water molecule is responsible for making the gamma form stable. So if I take out the water molecule, I'll have beta form. How to take out the water molecule? Condition where I did the solvent anti-solvent preparation, so water was there as anti-solvent. So now how to remove it in the same condition? If I can create a reverse temperature condition under which the water molecule went inside, if I take it out, it will be stable. So smallest curiosity can lead to understanding material in a different way altogether. And when you understand material, you can play with it. And once you play, you can create anything. I read one Russian lecture. They say that simple sugar cube, if we can find out the way to take out the energy of a 5-gram sugar, it will be equivalent to 1000 nuclear bomb. But you have to learn how to take out that 5-gram sugar's energy out of it. And probably, I don't know, हमारे योगी लोग शायद जानते थे कि वो बिना कुछ खाए, I think एक एक्सपेरिमेंट भी आप लोगों ने पढ़ा होगा, एक इनमास हमारे DRDO लैब में किया था. 15 days तक that scientist that yogi has not eaten anything and not has drunk anything, and he utilized his own metabolic outcome inside his body to be used by his own body to get the energy. Means a complete cycle of thermodynamic and kinetic control happened within his body. So depend upon your understanding of the materials and its energetics, its kinetic and thermodynamic control. You can design a material. You can design interface material. You can design a composite material. So that understanding, we verified it with that the converted one was exactly beta, for not having those peaks which was present in the gamma form, and we characterized its particle size also, and we found that the particle size was there. And among all the available processes, these all were the conventional processes: ball milling, solvent, anti-solvent, atomization, ultrasonication, supercritical processing, wet grinding, were not giving us the desired particle size. So innovative things was required, and that innovation cannot happen immediately. It has to result from some curiosity. So at academic level, as a research scholar level, if you don't have curiosity, don't expect innovation. कोई मुझे आके बोल दे कि तू अभी ना इनोवेट कर, फटाफट ये इनोवेशन चाहिए, that will not happen. Innovation will happen when you start observing your things curiously. So that curiosity should be there in your mind whenever you do any research problem. कोई भी, अच्छा आपको आपके प्रोफेसर ने बताया ये रिसर्च करो, ये करो. I tell you one more example. When I was in MSc class doing our experiment, we all know about catalyst, ना? Catalyst का reaction. 11th class में एक experiment करवाते हैं, ऑक्सैलिक एसिड एंड पोटेशियम परमैंगनेट का टाइट्रेशन, है ना? आप लोगों को सबको याद होगा. उसको गर्म करना पड़ता है ना, ऑक्सैलिक एसिड को बर्नर पे. तो मेरे माइंड में आया, मैंने कहा कि क्लास में अगर 50 बच्चे एक्सपेरिमेंट कर रहे हैं, 50 बर्नर लगेंगे, टेम्परेचर लेना पड़ेगा, फिर टाइट्रेशन करेंगे, फिर वो एंड पॉइंट निकालेंगे, कैलकुलेशन करेंगे. मैंने कहा कितनी गैस खर्च होती होगी, क्यों नहीं इसके लिए कोई कैटलिस्ट ढूंढा जाए. जस्ट एमएससी में फाइनल में था, तो हमने सोचा चलो इसका लिए कैटलिस्ट ढूंढा जाए. एंड यू नो व्हेन आई डिड लिटिल बिट लिटरेचर सर्च, एंड उस समय तो पढ़ के ही करना पड़ता था, सब कुछ इंटरनेट तो होता नहीं था. तो पता चला कि आप कोई भी एसिडिक कैटलिस्ट को ऑक्सैलिक एसिड से जो थोड़ा हायर ऑर्डर का हो, उसको कैटलिस्ट की तरह यूज कर सकते हो. क्या करना है आपको, वो कैटलिस्ट का मॉलिक्यूल ऑक्सैलिक एसिड को अपने साथ रखेगा, एक मॉलिक्यूल उठाकर रिएक्शन करके छोड़ देगा, दूसरे को उठाएगा. यानी यू नीड अ पिंच क्वांटिटी, not larger quantity. Generally, catalysts are required in that quantity. I found the ascorbic acid can be a good acid above the oxalic acid to be as a catalyst. And ascorbic acid costed 3 paisa per titration. So 3 paisa में आपका titration room temperature पे हो जाएगा, आपको बर्नर जलाने की जरूरत नहीं आएगी. So small observation, small curiosity, and can take you to develop the product. ऐसे बहुत सारे लोग हैं जिन्होंने बहुत छोटे छोटे क्यूरियोसिटी और ऑब्जर्वेशन को लेकर के बहुत सारे इनोवेशन किए. तो इनोवेशन का बेस है क्यूरियोसिटी ड्रिवन साइंस दैट कैन लीड टू टेक्नोलॉजी. फर्दर देन प्रॉब्लम केम, लेबोरेटरी में तो कर दिया, अब आगे क्या करना है. मेरी कंडीशन क्या थी, द रिएक्शन शुड हैपन इन ए स्मॉल वॉल्यूम, बिकॉज लार्जर वॉल्यूम में एज यू टोल्ड टेम्परेचर आई विल नॉट एबल टू कंट्रोल. तो स्मॉल रिएक्टर में कैसे काम करूंगा, मुझे तो किलोग्राम में बनाना है. अगेन यू हैव टू थिंक क्यूरियोसिटी. हम लोग सभी लोग जानते हैं पंप है, क्या मैं पंप हेड को रिएक्टर बना सकता हूं? पंप का हेड का वॉल्यूम बहुत थोड़ा होता है, जहां पर 1 और 2 को मैं मिक्स कर सकता हूं और वो कंटिन्यूसली रिन्यू होता रहेगा. सो यू आर द प्रॉब्लम ऑफ मैनेजिंग द टेम्परेचर विल बी रिमूव, बिकॉज इंस्टेंटेनियसली मिक्स हुआ, इंस्टेंटेनियसली रिप्लेसमेंट हुआ, इंस्टेंटेनियसली मिक्स हुआ, रिप्लेस हुआ. So we did another things, okay, how we can do this technology and product aspect. So we use this pump, you can see here pump, a small pump. उसका जो बल्क हेड होता है जहां पर इम्पेलर रहता है, उसको रिएक्टर में कन्वर्ट किया. उसमें एक इम्पेलर पे एक सॉल्वेंट को इंजेक्ट किया, दूसरे को इंजेक्ट किया. वो सक्शन पॉइंट हो गया, डिस्चार्ज पॉइंट हो गया. डिस्चार्ज पॉइंट पे प्रोडक्ट आ रहा है, सक्शन पॉइंट पे रिएक्टर के अंदर एंटर कर रहे हैं, कंटिन्यूस रिन्यूअल हो रहा है, एंड कंटिन्यूसली सर्कुलेशन पॉइंट ऑफ व्यू से यू कैन प्रोड्यूस अप टू 20 टन पर एनम स्केल. स्मॉल सॉल्यूशन, कोई बड़ा रिएक्टर नहीं चाहिए, कोई बड़ा कुछ नहीं चाहिए. टेम्परेचर मैनेजमेंट आसान है मेरे लिए, क्योंकि बल्क हैंडलिंग में कर नहीं रहा हूँ. और जब मेरा प्रोसेस मुझे पता है वेरी माइन्यूट थर्मोडायनामिक चेंज से इन्फेक्टेड है, तो मुझे उसे कंट्रोल करना जरूरी है. तो दिस वे वी रियलाइज इट टू बी अ process. This process is almost zero effluent discharge process, only desired form can be formed, and low temperature things happen. So handling is very easy, and we can characterize everything from that point of view. Their thermal stability and everything we characterize. Their size also we characterized. Particle size you can see we can prepare from 3 micron to 5 micron variation depend upon the conditions, and we prepare this. And no doubt our team was there to help me out. So a small curiosity that why this phase transformation? Why not that? Will lead to the product. So as an academician, as a researcher, as a student, if you work on the curiosity from your problem, half of the things. Rest happens technology and process. So with this, I thank you all for hearing me patiently and giving me this opportunity to share my thoughts. But keep your curiosity alive wherever you are, for whatever you are, for whatever you are doing, whatever you are doing. There is good learning, good science, good technology, good product can happen. Thank you. Any curiosity?
Dr. Soni, fascinating, fascinating how you actually ignited the passion as well as the curiosity among our students. And through
Thank you,
your
sir.
case studies and examples, you so lucidly brought how an ideation from ideation, how that passion will drive, Junoon will drive, to translate that through curiosity into an innovation. Great, great lecture. Maybe
you, sir.
students may like to ask some questions, Thakur.
Yeah, please, if any.
Dr. Lucky, can you read questions?
Yes, sir. So Professor Sikirwar wants to know that is there any possibility for our doctors?
Yeah, it's okay.
Sir, Professor Sikirwar wants to know that is there any possibility for doctoral students who are working on defense program to get scholarship from DRDO?
Yes, it's possible, but if suppose scholarship is not there from the parent institute, and if he has a net LS cleared, we can give them fellowship.
Mr. Nitish Raj wants to know that is there any internship program provided by your team or DRDO in the area of drone technology, basic to latest technology like swarms technology and etc.
I think my director better answer it.
Yeah, it's all this is possible, yes. 6 months internship, yes, possible.
Any other questions from the students who are sitting over here?
Are you working on any other material other than HMX right now?
Go next to the mic and ask the question next to the mic so that everybody knows what the question is.
So my question is, are we working on any other HMX, any other explosive material other than HMX?
Yep, presently, as you know, that in use are RDX, HMX, and PNP. But we have HMX, NTO, HNS, those are things. And I did not present it, but directors have shown that green energetics. We want new energetic molecules to come up, which has more nitrogen, more power, and less stability, less sensitivity, sorry, and more stable. So if you can think of new molecules, new energetic molecules which can be used, we are welcome. In fact, there is a complete session I can give on that. What are the challenges we face in energetic material technology? You know, not only new molecules, we want new processing technology, new production technology. And if you see, I dream a situation where you sit on a computer and suppose you have a series of energetic molecules lying up in your stock, and I want to prepare a missile. I just give a command, and then molecular assembly happens, and then a composite for missile happens. Then I give a command, a molecular assembly of suppose a warhead happens, means required whatever composition required, I need not to prepare in advance. I just can give a command and the molecular assembly happens and things become right. So zero wastage, zero effluent, minimum processing, maximum assembly. So that kind of challenges are there, and maybe we are welcome to have this make in India concept of things. You can start, probably we have to work on these lines. As our directors have told, that challenges are not small, they are big. But it starts from curiosity. Like if you say that why only HMX I am using, first curiosity, then you will say any other is possible, another level of curiosity. Then you come up with the new molecules. You will say it is better than this one. Then we will start working on one.
Can we start a project of your dream which says small molecules and preparing one and actually launch something?
Surely, sir, welcome.
So start. We have always start with 2 molecules or 3 molecules.
Because that is required. I tell you, nobody, and I'm about to share one more incident. One of my friend who is into this lot of things. You know, कुछ सालों पहले हमारे इंडिया में गेहूं हमारा पास नहीं उगता था, है ना? आप लोगों को शायद पता होगा। आज तो गेहूं आप एक्सपोर्ट करने की कंडीशन में हो। कुछ सालों पहले तक, आई थिंक 10-20 साल, 25 साल पुरानी बात होगी, गेहूं इंपोर्ट आता था। रशिया एंड यूक्रेन collectively export 30% of wheat of the world. और आज क्या हालात है पता आपको? यूरोप में wheat नहीं मिल रहा बिकॉज सैंक्शन लग गए। अमेरिका खुद भी नहीं ले सकता और दूसरों को भी नहीं दे सकता क्योंकि खुद की रिक्वायरमेंट पूरी नहीं हो रही है। आज हमारे कंट्री में अगर wheat नहीं होता तो हमारी क्या हालत होती? आज हम सेल्फ रिलायंट हैं and I think probably today or tomorrow our government will take a decision to export wheat to Europe. First time in the world history when India will give wheat to the Europe for meeting their food requirement. So 20 साल लगे हमें, 15-20-25 साल लगे होंगे wheat में आत्मनिर्भर होने में। डिफेंस टेक्नोलॉजी में आत्मनिर्भर हुआ जा सकता है क्योंकि पेट की भूख अगर बुझ सकती है तो बाकी जरूरत भी पूरी हो सकती है। स्टार्ट करने की जरूरत है। कोई भी टेक्नोलॉजी इंडिजिनाइज करने में, आत्मनिर्भर बनने में ज्यादा टाइम नहीं लगेगा। बट वी हैव टू स्टार्ट समवेयर। May take 5, 10 years, 15 years. Possible, and it has to be done.
Your ideas are excellent. Actually, very much viable and perfect idea. Start to make a base of this could be a good start.
One thing I just want to add, I just want to add one point, what Sony just said. Somebody asked about energetic new materials other than HMX. As I think the slide also is showed that it is, I think, 22 years now since 2000 that we are still stuck on to HMX. It is not that the world is static and they don't have any other energetic material. It is not, since it has military application and therefore it will not come in public domain maybe for quite some time. By the time there's some other higher grade materials are available. Therefore, we have to take this opportunity to start working in developing these molecules, and these are not going to be a very small time affair. There has to be a continuity. And because when we are talking in terms of energetic molecules, it is not only the energy content that we are looking at. Also, we have to look at the stability. Because it should not be an auto-decomposing compound. And over a period of time. So which means if I process it today, synthesize it today and process it today into some kind of a system, it should retain its property over a period of about 30 years. So that is the challenge. That is, and second is if I don't start today, whenever you start, it will still take that much time. So best is, I mean, in all these areas, as early an early start is always the most welcome step. We will have certain challenges. We have certain challenges, but that should not deter us from taking such kind of problematic areas or challenging areas to tackle on. Somebody has to tackle it. Somebody has to tackle it. So somewhere we have to make a start, and that is what one of the core focus area for TBRL. What we are looking at is, why can't we start working on a new energetic molecule? We may have stability issues to start with. We may have processing issues to start with. We may have bulk production issues to start with. So let's start. Somewhere we have to make a start. So one area, one very key focus area for us. And we have all the
all over R&D cannot,
Yeah.
Global cannot just have the knowledge continues. But knowledge repository much faster, much deeper. Therefore, very opportune moment to have a partnership for such kind of things, which have today it may look very, very difficult, but everything in the beginning looks very difficult. Today it looks very simple. So starts have been made. So this is one area where I am also looking for new energetic molecules, and then looking at all aspects in totality. That is, its processing, its storage, its sensitivity, handling, bulk processing, everything put together. And just the second question of looking into the point what Dr. Soni brought out, the innovation point, and something which is which has a future implication. As again, we have to think, the one thing which I said, you have to foresee the future, predict what is going to happen 20 years down the line, and accordingly work towards it. So what he is saying, it may look to be a very, it may look to be a fictional thing, but every science part had a fiction start. So let this be a fiction start, and things are possible unless we ideate, we cannot actually convert. So these type of things are required in defense technology. Such kind of, you can say, radical innovation. I mean, you can always go with incremental innovation, but incremental innovation, by the time I reach my goal, my goalpost has already moved out. I'm out of the game. So I have to have certain kind of radical innovation, something which is very untraditional, very unconventional. We have to take that risk. We may not succeed also. Not every R&D effort actually results in a success. We are very well aware of that fact, and we are ready to take that risk. That is what R&D is all about. For the fear of failure, if I don't start an R&D work, then that's not R&D. Even getting a failure in an R&D is an achievement. Otherwise, there's all the bulbs that we are enjoying would never have been invented had Edison stopped at 100. It was the 104th material which he attempted, by which he got the filament. Had he stopped at 100 and I'm done with it, we would not have, maybe we would have waited for the bulb for 120 years for somebody else to come up with this. So the risk of failure in R&D is an integral part of it. We have to have that patience to actually handle it, face it. And today we have to invest in it, then only tomorrow we will be successful. So that is one thing. I mean, to academic institutes also, we have to have that capacity to absorb failures. R&D institutes, we have also had similar issues. We always, and if we start looking at low-hanging fruits, I don't think that's going to lead us anywhere. We will continue to remain followers only. If we have to be the leaders, we have to have our own original thinking. We have to have the capacity to absorb losses, absorb failures, and learn from the failures to work on to the success. That's how I would like to put it. So every innovative idea, everything which looks to be totally out of sync today, will be the sync tomorrow. So that's how we have to take it. And in technology, nothing is impossible. Whatever idea comes, if an idea comes, which means sooner or later the conversion also will happen. Better make it sooner than later. That's how I put it. There is no fixed guideline, depends on the usage, depends on the operational condition, depends on the storage condition. There are various mechanisms by which there are electric during the storage, during the transportation, handling, safety, and there are certain standard tests that are prescribed. Everything has a threshold. It is not that I can make it proof. I can make it resistant. Like earlier times, we used to talk in terms of bulletproof jacket. If I say bulletproof jacket, which means every type of bullet it will stop. So what we are now saying is it's a bullet resistant jacket. Up to a certain extent, it will absorb. It will cause some blunt trauma, which will be not detrimental for the person wearing it, but it will cause some superficial damage, but he will survive. So, but if I use a very high velocity bullet or a high caliber bullet, a bulletproof jacket is not meant, a bullet resistant jacket is not meant for that. So everything will have a limitation, because when we talk in terms of a product, it is always based on certain assumptions. I have certain knowledge, and then I assume, let us assume, every time when we start solving the problem, we start like that only. So how good is my approximation to my reality? This gap is the uncertainty. Now, this uncertainty is what actually makes it not proof but resistant. So if we can make it resistant, like explosives. There are explosives like primary explosives which are used in detonators, which is very, very sensitive. If you drop it from this height, it will make it. There are explosives where actually you can impact it with a velocity of 800 meters, 1000 meters, 2,000 meters, also it will not detonate. It has that kind of a capacity to absorb. But that does not mean that a fellow which is withstanding 2000 meters per second impact will not go off at 5000 meters per second. So that is why you can delay the failure. You can create a condition which is very difficult for a system to be created outside for the system to fail. But there is nothing called proof. It will fail. There no system is a failure proof system. You can delay the onset of failure.
So we have a question from Professor Sigarwal. He wants to know that they are having a very good drone team and they are designing and fabricating it for defense applications. So can your lab give them the opportunity for getting a project on drone development?
Possible, yeah. It's a team of research scholars or faculty members.
They haven't mentioned it, sir, but he's
anyway, I think we can work it out. Yes, I mean there are live problems which you would like to discuss separately.
And Nimani Kumar wants to ask that hypersonic missile defense systems and technology, what is India's progress in this area of research and development, and how students can work on it?
I will suggest, maybe they can write, there's a lab in Hyderabad, DRDL, which is actually working on these kind of technologies. So maybe they can work on it. As on date, the hypersonic missiles defense technology is a very, very gray area. It's a very, very gray area as on date, but there are people are working on it, and maybe this, the people who are asking this query can refer it to DRDO headquarters or to DRDL in Hyderabad, Defense Research and Development Laboratory in Hyderabad, which is actually working on these kind of systems.
Thank you so much, sir. And now I would like to request Dr. Selvamoorthy, sir, to give his concluding remarks.
Thank you. Thank you very much. Shri Pratik ji, Dr. Soni, first of all, gratitudes to you both for this wonderful exposition, deliberation, and I am very proud of our leaders like you, Shri Pratik ji, as well as Soni. And Shri Pratik, your depth, breadth, and understanding of defense technology and the impact you have made in this field is immense. So we are very grateful to you that you found time to be there. You are a professor also, because I can see the professorial way you handle the questions as well as your deliberations in a very, very lucid and simple and presentation wonderful. So thank you so much. Actually, founder president has given us a mandate in Amity that Amity has to be #1 contributor in the field from among the universities to DRDO in the field of defense technology. So now I would appeal to all my faculties, PhD scholars, MTech students, tremendous opportunity available today. You know, he mentioned about if you have a PhD problem related to defense, go to the appropriate lab, they can give fellowship. Similarly, MTech, actually tomorrow I'm going to talk to Secretary also, Secretary DRDO, on this, what kind of support we can give when they go for 1 year, because 1 year these students are going to be with the laboratory. So what kind of motivation, inspiration, support, and also to carry on that mission of the project is done there. So how do we use this IPR generated in the laboratory and the DRDO? So MTech not only in defense technology, even in the mechanical engineering, electronics, computer science, tremendous opportunity. So please apply for these schemes. Similarly, the boards, which is a research boards, which we have 4 research board, apply for projects. I would like to tell the faculties and scholars that please apply for the projects. The lab itself can give 25 lakhs if the director is convinced that yes, there is a project which is viable and will be useful, futuristic, and will make an impact in the Atmanirbhar Bharat. They can immediately give 25 lakhs. And similarly, up to 3 crores, you go to the headquarters. So these are all opportunities, but how you harness? I want all Amitians who are here on the screen, who are not in the screen, please spread this message that we must be the #1 contributor to defense R&D in DRDO through as an academic partner. So this is the message is very clear, and I'm sure we will do that. Prateek, I want to tell you also, we have a campus in Mohali that will be just next door to you. So in the Mohali, we have started a young university. It is just the recruitment has started, the constructions are on, and that will be next to your door. So I would give the message to the Vice Chancellor that you are here, and I will request him to invite you at appropriate time when things are settled there, and you can go and use this as your. So Amity is your organization. Anything which you want us to do in research, development, the basic fundamental research, futuristic technologies, disruptive technologies, quantum technologies, all this AI, IoT, and machine learning, deep learning, all this, our people are there. So this research cluster, defense technology, where we have requested Dr. Atul Thakur to be the coordinator. So he is driving this. We have 18 cluster, and this is one of the most important in Atmanirbhar Bharat is defense technology cluster. This research cluster not only will work in, it is going to unite all the capability in the Amity group. Haryana campus may have some capability and expertise. The Uttar Pradesh campus, our Noida campus will have some capability. How do you integrate them? So we have formed cluster. Like in DRDO, we have this armament cluster, which TBRL belongs to armament cluster. So in Amity also, we have made research clusters, which is really doing a great job. And this defense technology cluster will give many valuable input to you, the DRDO, but also to TBRL. So also look for collaborative projects, preferably futuristic. Academic institution should imagine something new, not just look at the Google and then make something improvisation, but think disruptively, innovatively, and ideation and imagination are the most important thing, which is very important. And I'm sure all the message has gone deep into their heart, mind, and soul. Shri Prateek ji and Dr. Soni for this wonderful job. And I would request you to visit other campuses also sometime in Uttar Pradesh, Noida campus. Then we have also Mohali, I said, and we have Bangalore, one new campus is coming. So we also need good people. So I would request Prateek ji, if you have some good scientists after retirement, they are looking for academic appointments, we would be very happy to consider their employment in Amity Group, particularly in these Amity University Haryana and Amity University Uttar Pradesh, where we have started the defense technology. So please encourage your scientists after superannuation with that rich wisdom, knowledge, expertise. They can come and serve, mentor these students, PhD scholars, as well as the MTech students in defense technology. So with this, once again, I thank Shri Prateek for this wonderful initiative to come to our campus. So my salutation to you and to Dr. Soni for having been present here. But this should, now we want to follow it up because the founder president, Dr. Chauhan, has started a mission outcome. Once you have come spent so much, almost half a day or 1 day here in our campus, what is the outcome for you and what is the outcome for Amity? So it should lead to a sustainable outcome so that will yield fruitful results for both DRDO as well as for Amity. So with this, thank you once again. And let's give a big clap for Yes, sir.
Here is the president.
Yes, founder president, sir. We want to hear the last word.
I would say 100 marks out of 100 to both of them. It was so exceptionally unparalleled, useful, and also big clap for Dr. Professor Pradeep Kishorji, Professor Pradeep Kishorji, and Dr. Soni. And I think I heard every word. It is something so amazingly useful for us, amazingly useful. And Dr. Murthy, I was reading the protocol of your last marathon meeting of 3 hours. You have ticked there that our student will be in touch with them. You had made 3 columns, their lectures. Now Thakur has done it today. Then our student will visit with them and other student may take training with them. So I would say to Dr. Thakur and P.V. Sharma to send a batch of about 20-25 students to visit their labs, because both Professor Srivastava, Professor Pradeep Kishorji is so visionary, what all examples they gave, and also Dr. Soni, as Dr. Soni is rightly a professor, the way he was speaking. So I would say very useful. Dr. Thakur, send the recording to also to my Vice Chancellor, Professor Dr. Kohli at MIT University, Mohali. They
Sure,
are,
sir, sure.
they are sitting nearby, and they will invite TBRL to visit MIT University, Mohali, and they would also visit. Dr. Shamurthy also start eventually from this session or in July,
Right,
MTech Defense Technology also in Mohali.
right. We'll do that.
The people in Punjab are fighters.
Right, exactly.
So that will be the right place to start MTech Defense Technology. And Kohli is a hardcore, formerly, Pradeep, formerly Vice Chancellor of Punjab University, and a hardcore technocrat. So he is now my Vice Chancellor. So I think we'll bring contact with them. And all my compliments to students and to Dr. Thakur. Send me a list of all who were attending today. It was very good. I could see that a large number of students are attending. And I will send you the recording, and we'll send the recording also to Professor Kishorji and also to Dr. Soni, so that they can also hear that whatever they have spoken will be followed together. Thank you very much. Thank you very much.
Thank you, sir. Thank you.
Thank you, Founder President, for your gracious presence all through these deliberations you have been watching. And that is how you were able to make an impact on the young minds, particularly the MTech students. Prateekji, this is the commitment Amity has, Founder President has. The Founder President wants to be the #1 contributor to Atmanirbhar Bharat, particularly in the defense technology domain, and we will do that. The message was very clear to each and every Vice Chancellors and also the faculties and students. So thank you so much, and visit us more often. And we would like to contribute. Amity now is yours. So anytime you say that you are coming to Delhi, that I want to visit Noida, please immediately we will arrange. It's your university. Thank you.
Thank you very much, sir, and it's an honor and privilege for us to be here and associated with SFMT University. Thank you very much, sir. Thank you very much.
Thank you.
Now I would like to invite Major General. Now I would like to invite Major General G.S. Burl for the vote of thanks.
You've just heard the concluding remarks of Founder President and Dr. Silva Murthy. It now remains for me to thank Professor Kishore and Professor Dr. Soni on behalf of the Amity University for having taken the time off for coming here and enlightening us about the DRDO. Let me say that we have learned from our history. 1962, we learned that you can't fight the Chinese with bolt action rifles. 65, 71 operations taught us that we need to do rapid modernization of the armed forces. The 1999 Kargil war taught us that self-reliant is the only way forward in this the earlier bipolar world, now converting to the multipolar world. If India has to be part of the world order, we have to be self-reliant. And the wonderful initiative which has been taken by the Prime Minister of Atmanirbhar Bharat is a focused movement in that direction. And I was most learned about what the synergy that we've been able to achieve, as Dr. Prateek said, that the DRDO, the industry, academia, and the armed forces, they all come together in synergy to make sure that we attain this self-reliance. And that is what the direction forward is. So on behalf of all of you, I would like to once again thank you, sir, for giving us this wonderful exposure on the DRDO and what the DRDO has done for us. I have been associated with the DRDO for a number of years, like we were discussing. My interaction started with the DRDO in 1981 when the first Arjun tank was evaluated as a prototype, and then number of trials that we held. And like I was discussing with you, that earlier on we were working in compartments. The army was working in a separate compartment, the DRDO was working in a separate compartment, and the industry was more or less not in sight. But things have changed. And I think we've got our act in order. We are all focused. Like in 1999 Kargil War, 2 examples I'll give you. When we wanted the GPS inputs from the Americans, the GPS was switched off by the Americans. They did not give access to the GPS. And after that, we developed our own navigation system. We developed our own satellite system, which is not global, but it's regional. And the second example that I would give you is the Bofors ammunition really ran out, and we did not have a place to look for the ammunition. Had we been self-reliant at that point of time, we would have manufactured our own ammunition. I am a tank man. I know also that the ammunition that we have in the tanks is, we have a limited quantity because all of it is imported. And the DRDO is doing a wonderful job by developing that ammunition. And I'm sure that the next 1 or 2 years, we'll have our own FSAPTS ammunition, which would be as good as any other ammunition in the world. So on behalf of our founder president, the chancellors, and Dr. Silvamurthy, and our Vice Chancellor, Dr. P.B. Sharma, and the entire fraternity of Amity University, Haryana, once again, thank you very much, sir. I would also like to thank Dr. Thakur for having put this together in a very short period of time. In fact, I think you just got 48 hours notice to put all this together and very wonderfully organized. I would like to thank Lucky for having introduced the complete the conference today. And I would like to thank all the students sitting here for asking such wonderful questions and listening with interest and patiently. Thank you very much, and Jai Hind.
Let's give a big clap to Dr. Atul Thakur. You please follow up. Huh? Great job.
Thank you, sir. Thank you.
And please take care of them, take them for lunch, and
Yes, sir.
also take care of them. Show them
Sure, sir,
around
sure.
the laboratories also, and
Yes.
depending on their time and convenience. So please ensure that they see also some of the important facilities. Thank you. Thanks to all the students. Let's give a big hand. Let's clap for students. Wonderful job done. Thank you.